Hello, thank you for watching this video. So in this video I'll be doing question 5 of November 2023, question mathematics paper 1. And these are trigonometry principles. So like basic trigonometry. So let's go. 5.1. Given that sine beta is equal to 1 over 3, where beta is between 90 and 270 degrees. Without using a calculator, determine each of the following. Okay, so you are given that sine beta is equal to 1 over 3, right? And you're told that your angle beta here is between 90 and 270. Your angle beta is between 90 and 270. That's what you're told. So, what do they want you to do? So they want you to find the value of this without using a calculator. So it is difficult or not very easy to find the value of cos beta or any of the other things that you'll be asked without a visual representation, right? So you need to draw some sort of a rough sketch like this. Draw the rough sketch of the situation. So you have 0, you have 360, you have 90, you have 180, you have 270, you have 360. No problem. So they are saying to you that your beta, which is your angle, is between 90 and 270. So your beta is between these two positions, between 90 and 270. It's either this quadrant or the third quadrant. It's measured between the second or the third quadrant, right? No problem. So you are given that sine beta is equal to 1 over 3. So this thing here, 1 over 3, is positive, right? So you know that sine beta is equal to 1 over 3, and 1 over 3 is positive. Since 1 over 3 is equal to sine beta, and 1 over 3 is greater than 0, that means sine beta is also greater than 0. I'm saying, if you are saying sine beta is equal to 1 over 3, right? And 1 over 3 is greater than 0, which is positive. What that means is your sine beta is also positive, which is this. Sine beta is positive, which is above 0, greater than 0. So in which quadrant is sine of an angle positive? It's either on the first quadrant or the second quadrant, right? But in our case, we know that the beta is between 90 and 270, so it's between 90 and 270. But we know sine is negative on this quadrant. So the only quadrant where sine is positive is the second quadrant. How do you decide? You are given the range of your beta, that your beta is above 90 but less than 270, which is between 90 and 270. That's where your beta is. But you know that your sine of beta, which is sine of that angle, whatever the angle is, it will be positive, which means if sine is on the given quadrant, on the possible quadrants, is only positive on the second quadrant, on these two possible quadrants. So we know that beta lies on the second quadrant. So we can say, okay, our angle beta is measured from here anti-clockwise to here. So you have your what? Your beta there. So you can complete this by saying, okay, have this right angle triangle here, sine. You know that sine beta is equal to opposite over the hypotenuse side, right? So if this is your beta here, your opposite side is this one. So you have 1 here, right? And your hypotenuse side is the longest side of your right angle triangle. So it's this side here. So this vertical side is 1, and this hypotenuse or slant side is 3. So what you don't have now is the horizontal side, this side here, which is x. How do we get this? You say r squared is equal to x squared plus y squared. R is your hypotenuse, which is 3 squared, is equal to x squared, which is what you're looking for. plus y squared, which is what? Which is 1. So you will get that your x squared is equal to 8. Then take the square root, plus or minus. The x is equal to plus or minus of square root of 2 root 2. That's the square root of 8. Square root of 8 is what? It's 2 root 2. So this is your answer. But on this side, which is on this side, or maybe on the second quarter, x values are negative, right? If you're on the second quarter, the x values are negative. So we should take the negative x value here. Therefore, our x is equal to negative 2 root 2. So our x is equal to minus 2 root 2. Minus 2 root 2. That's our x value. No problem. Then now, with this triangle being complete, you have all the sides of the triangle, you have your beta as well. You can find the value of what? You can find the value of cos beta, which you were asked in the first place. So you were asked the value of cos beta. You know, cos is equal to the adjacent side of beta divided by the hypotenuse side of beta. So let's go there. Your beta is here. Your adjacent side is this one here, right? So it's your minus 2 root 2. And the opposite side of beta is that one over there, and this one is the hypotenuse. So your adjacent side is this one. Your opposite side is this one, and your hypotenuse is 3. So your cos beta is equal to minus 2 root 2 over 3. We're done with this one. Then we move to the next one, 5.1.2. What do they want? They wanted to find sine 2 beta. This is what they wanted to find. They wanted to find sine 2 beta. No problem. So, you know that this is a double angle, right? So it is equal to what? 2 sine beta cos beta. So which is equal to 2 sine beta times cos beta. So what is sine beta? What is sine beta? You come to a triangle. You know, is sine beta is equal to the opposite side of your triangle over your hypotenuse side of your triangle. And cos beta is the adjacent side of the triangle over the hypotenuse side of your triangle. Then you go to your triangle. What is the opposite side? The opposite side is 1. The hypotenuse side is 3. So you have 2 times what? 1 over 3 times the adjacent side. What is the adjacent side? The adjacent side of beta is negative 2 root 2 minus 2 root 3, negative 2 root 3, or negative 2 root 2 divided by 3. Therefore, your sine 2 beta is equal to the simplification of that, which is minus 4 root 2 over 9. Looks something like this. This is your sine 2 beta. So you know this. This is your compound angle from, this is a double angle from your double angle expansions or your compound angle expansions. So we're done here. We'll move to the next one. 5.1.3. What are they asking? They're asking to find cos 450 minus beta. This is what they wanted to find. Cos 450 minus beta. So, what I always do is, if the maximum that I have here, that does not lie between 0 and 360, I always reduce it, right? I'm not comfortable working with the maximum that is above 360. I would rather have something that is between 0 and 360, something that will fall within this boundary here, right? So how do you do that? So when you have a maximum that is above, when your maximum is above 360, which is this number here, it's above 360, subtract 360 until it is within this boundary here, right? Between 0, until it's between 0 and 360. If this number here is less than 0, which is it's negative, add 360 to it until it comes up here, because this is a more familiar ground to work on, at least for me. I don't like that one. So if I have 450, I'll subtract it by 360. So I get that if I subtract 360 here, I'm going to get that this thing is equal to cos 90 minus beta. This is what you get. Okay, so you have 90 minus beta. In which quadrant do you get 90 minus something? You get that on the first quadrant, right? You get this on 90 minus beta on the first quadrant. So what sign is cos there? Your cos is positive, right? But because your maximum is 90 or 270, if your maximum is 90 or falls along this vertical line, your function changed to its co-function identity, right? Which means that you had cosine of 90 minus beta. So you said 90 minus is on the first quadrant, and in that quadrant cos is positive. But because the maximum is falling along this vertical line, it's 90 or 270, your function cosine will change to its co-function identity, which is sine beta. So your cos 450 minus beta is equal to what? Is equal to sine beta, which is equal to 1 over 3. Because sine beta is equal to the opposite. The opposite is 1. Your hypotenuse is 3. Right? Which is what you've given anyway in the first place. So this is how to do this first question. So we'll move to 5.2. I would like to clean the board so that we have all the space for 5.2, and then we continue. Hello. So now we're doing 5.2, right? So on 5.2 you are given this thing here, right? So you are given this thing, as you can see it. They want you to prove that this thing of yours is equal to 1 minus sine x, right? So they want you to prove that the left hand side and the right hand side are equal. But if you look on the left hand side, on the right hand side, there's nothing much that you can do, right? Because this thing has been simplified already. But at least here on the left hand side, there are some things that you can try. So if you want to prove that the left hand side is equal to the right hand side, we will choose to take the left hand side, right? And then now, what do we do? We have cos to the power 4, 4 raised, or cos x raised 4, right? So what do? You can say, okay, you have cos squared x times cos squared x, right? Which is this, plus sine squared x times cos squared x, all divided by what? This is all divided by 1 plus sine x. So, and then from here, you can see that you have a common factor, which is cos squared x on both sides of the sum sign. So take cos squared x as your common factor, cos squared x. What we have in here, we're left with this guy, which is cos squared x. Actually, let's say 1 times cos squared x, because this is where the other cos was sitting, right? Plus sine squared x times 1, all divided by what? All divided by 1 plus sine x. So let's simplify. So you have cos squared x. 1 times cos squared x, it is cos squared x. Sine squared x times 1, sine squared x all divided by 1 plus sine x. This is what you have. So you know this is an identity because you know that cos squared x plus sine squared x is equal to 1. Right? So this is an identity here. So which means if I continue with that, if I continue with this, what do I have? I have cos squared x, right, times what is inside here, which is 1, all divided by 1 plus sine x, which is equal to cos squared x over 1 plus sine squared x. Right? From this same identity, you can solve for your cos squared x from here, because you have cos squared x plus sine squared x equaling 1, right? So your cos squared x is equal to 1 minus sine squared x. So which means your cos squared x is equal to 1 minus sine squared x, right? But if you're looking here, if you look from this, you can see that you have cos squared x over 1 plus sine x, right? That's what we have. So which means cos squared is equal to this from the same identity as that. Cos squared x is equal to 1 minus sine squared x. So what do? When you see your cos squared x, you substitute your 1 minus sine squared x divided by 1 plus sine x. What do? You can see that this is more like 1 squared as well. So it's a difference of 2 squares. So you do this, you have 1, you have sine x, you have plus x, you have minus, right? All divided by 1 plus sine x. So you can see that this bracket and that cancel away, and you're left with 1 minus sine x, which is equal to the right hand side. Done. Because this is what we wanted to show anyway, which is this. We're done. Straightforward. Right? I hope so. So let's continue. 5.2.2. Okay, so now we're doing 5.2.2, right? What does this thing say? It's asking for what values of x on this interval from 0 to 360 is this thing here undefined, right? They're asking what are the values of x where this thing is undefined. So if we were to look at cos to the power of 4 x on its own and look at those two, the product of these two things, cos squared x, sine squared x, and this one, 1 plus sine x. If I look at them separately, actually, let's look at them separately and see their behaviors. This, what you have here, it's more like sine x, right? All squared, right? And this is equal to this all squared. So this cos, this is actually this, and this one here is that. You know the exponent laws, right? And this is this one, as you can see, it's very clear, this one. You know the function of cos x. The function of cos x is defined for all values of x. So this thing here, this one, will have values for all x and element of real numbers. This one, because it does not have any asymptotes, right? So for all any x value that you can think of, and you substitute it there, any value that you can think of, and substitute it there, it will always have an answer, right? For example, let's say cos 700. If you punch cos 700 and you get an answer, then cos is defined at x is equal to 700, right? That's what it means for a function to be defined. This thing have a value at any values of x. This is what I'm trying to say. This cos x all squared, it will always have a value because this will always be defined for all values of x. This is the same thing as this one, cos x here, and that's sine x. Sine and cos, right, have the values anywhere on the real line. So for any real number that you substitute there and there, you will have a real answer. Do you understand? Same thing with this one. If you substitute any number there, you will always get an answer. So that's what it means for these things to be defined. Each of them to be defined, because I've separated them. So we can say that this will be defined everywhere, this will be defined everywhere, and this one will be defined everywhere if you look at them separately. If you look at them as different functions, those all three functions, this function, and that function, would all be defined. They will always have values for any x value that you think of. So that's why I'm saying their domain is this, because they're defined everywhere. Right? No problem. So even on the restricted one, this will always be defined, this will always be defined, and this will always be defined. By that, always defined, I mean for every value of x that you think of. You will always get an answer for this, you will always get an answer for this, you will always get an answer for that. Even though they are all defined, they are defined everywhere combined or separately. If you combine them, it's a different story, which is what they are asking us here. So they are asking us about a combination of all of them, right? So let me clean this and then go back to the combination. Okay, so now we're dealing with the combination. So this will always be defined, the top part, and this part will always be defined, and this one will always be defined in this form. But if you look at the entire fraction, right, you know that if your 1 plus sine x becomes 0, right? Let's say at some point, maybe at x, let's say maybe at some point, right? So let's say maybe at some point, you get that your denominator 1 plus sine x is equal to 0. If your x plus sine x, which is your denominator, which is if this part, this lower part here, if this lower part here becomes 0, then you will have problems, because you will have your answer at the top, which will be defined, right? Divide by 0. What is the answer to that? You don't know the answer to that. So let's say your answer maybe was minus half, right? Let's say the top numbers were giving you minus half, and then now the bottom one is 0. Then this is not defined because you don't know the answer to it. Even if you can punch it on your calculator, it will give you some error or something. So this fraction or this fraction is undefined if the denominator is equal to 0. If you have a fraction, right, like this, it will not have values if you are dividing with 0, because if you divide with 0, you know you will have problems. So when will it be undefined? It will be so this thing, this entire expression or fraction here will be undefined if the lower part is equal to 0. Do you understand? So what are those values of x that will give us 0? So we solve for x here. So we say sin x is equal to minus 1. Then you find your reference angle. You will see that your reference angle is 90 degrees, right? But you see that your reference angle is equal to 90 degrees. But you know that on whatever quadrant this angle x is, right, the sine is negative, right? Because here on the first one, we said because sine beta was equal to sine 1 over 3. 1 over 3 is positive, right? Then by default, sine beta was positive in that, or sine was positive in that quadrant, or sine beta was positive. So in this case, we say sine x is negative, right? So which quadrant is sine x negative between 0 to 360? You know that it's the third quadrant and the fourth quadrant. That's where sine is negative. And on the third quadrant, you say your x is equal to 180 plus your reference angle, right? And on the fourth quadrant, you said your x is equal to 360 minus your reference angle. So your x is equal to 180 plus 90 degrees, which is equal to 270, or your x is equal to 360 minus 90 degrees, which is the same as 270. Right? So which means on this interval, right, from 0 to 90, 0 to 360, this will be undefined where? It will be undefined for at x is equal to 270. Because at x equal to 270, if you plug your 270 here, let's say, if you plug your 270 here, you'll see your answer is 0. Which means then now, you will have a situation where when you divide by 0, you won't have an answer. So that's when this thing is undefined, which means you don't know the value of it. You don't know the definite value of it. I hope that makes sense. Then we move. I'm going to clean this part. Then we move to 5.3. 5.2.3. So now we're doing 5.2.3, right? That's saying write down the minimum value of the function defined by y is equal to this thing. So you have a function y defined by this. So they want the minimum value of y. That is what they want from you. They want the minimum value of this thing. Right? No problem. Minimum is the smallest value of this thing. So you say, okay, my y is equal to cos to the power of 4 of x plus sine squared x cos squared x all divided by 1 plus sine x. Right? So I'll assume that, actually, let me not make any more assumptions. So I know that this will be equal to, or I prove that it is equal to 1 minus sine x, because we prove for where? For x is not equal to 270 on the interval x is from 0 to 360. So y, which is this, is equal to this one. For x is not equal to 270, because at x equal to 270, this one will be defined, right? So what I'm trying to say is y, which is equal to this, is defined, which y, which is this, is equal to this thing. For x is not equal to 0, for x is not equal to 270 on this interval. So work with this interval, because that's what on this interval I know where these two are equal. Right? Then whatever that I get there, I'll extend it to the entire domain. So I'm saying that these two, this and this, are equal for x is not equal to 270 on this interval. they will be equal anywhere here except for that point, right? And you know, the reason I'm saying this is because this part will be equal to 0, right? At x equal to 270. And you will not be able to find an answer to this one here, to the left-hand side. But on the right-hand side, you will be able to find an answer. Because if you say sine of minus 1 minus sine of minus 270, sine of 1 minus sine 270, you get something along the lines of 2 as your answer, right? So this one is defined and this one is not defined. So to say that these two things are equal is not really correct if they are only equal at certain positions and other positions are not equal, because that is one of those positions where they are not equal. So you must specify that in the domain which you are working on, but no problem. So now we say this is equal to that, right? So we say y is equal to 1 minus sine x for this domain here, or maybe for these conditions here. Yeah, for that domain then. Then, if you look at it, this is y is equal to negative sine x plus 1. I've just rearranged the order. So look, you know that your natural sine have this range here. It's greater than minus 1, less than 1. Then, even your minus sine will have the same range. Because if you multiply by minus 1, you will get this thing here. Right? What I'm trying to do, I'm trying to achieve this. So, I said the natural one that you know, the natural range of sine is this one. Then if this natural range you multiply by minus 1, this is what you get. Right? Then now, for this to look like that, I must add 1. So you say, okay, I'll add 1 here, add 1, add 1. So I have 0 greater or equal to 1 minus sine x less or equal to 2. Right? And this is your y. So 0 is less or equal to y, less or equal to 2. So this is your function, which is this thing here. So this is its minimum value of the range, and this is its maximum value of the range. So your minimum value of y is equal to 0, and your maximum value of y is equal to 2. Done. Done. Okay, so now we are doing 5.3. 5.3 reads as follows. You are given that cos A minus B is equal to cos A cos B plus sine A times sine B. That's what you are given, right? So they want you to use the identity above, right? They want to use the identity above to deduce this, right? So they want you to use this identity up here that they've given you to show that this is the case, right? No problem. What do? We say, okay, we know that we're given sine A minus B, right? Which is equal to, look, you know when you're doing your trigonometric simplifications, you say, okay, if you're given something like cos 90 minus theta, you will say, okay, which angle is this? Which quadrant is 90 minus? 90 minus is found on the first quadrant, right? Right. What sign is your function? Say it's positive. But because your maximum is 90, or is along the vertical line, because if you think about this thing, it's like this. You have 0, you have 90, you have 180, you have 270, you have 360, right? So if your maximum lies here, as you can see, then this function will change to its cofunction identity. It will become what? Sine theta. Same thing. If you have cos 270 plus theta, you're asking yourself, which quadrant is 270 plus? 270 plus is on the third quadrant, right? What sign is your function? My sign is what? My function, cosine, is positive, right? It's positive. Therefore, this function will change to its cofunction identity, which is sine theta. You know that. Okay, so from this now, right, what can we say? We can say, okay, our sine A minus B is equal to what? Is equal to cos 90. Actually, cos 270. Cos 270 plus A minus B. Right? Looks more like this. Because what we just did here, we just reversed this and asked ourselves, where is this thing coming from? If you see, if you have sine theta, it can be equal to this or it can be equal to that. I'll tell you why I took this one. So we can simplify this and say it's equal to cos 270 plus A minus B. So, and group these two. So that this looks like your A, which is this part here, and then this looks like your B, which is this part here. And you can see that there is a minus here, which is this minus here, which is good. But had we taken the 91, we're going to have problems because the negative of 90 was going to make this one negative and make the other positive. Actually, it was going to come out the same, as long as you arrange them in a perfect way. No problem. So what we do? What we do now, we expand. We expand this according to this compound angle expansion here. So it will be cos 270 plus A cos beta plus sine 270 plus A sine B, right? Then you ask yourself, in which quadrant is 270 plus? It's on the third quadrant, right? Actually, it's on the fourth quadrant. What sign is your function there? It's positive, but because the maximum is along the vertical line there, it will change to its cofunction identity and become sine A times cos B, right? Plus 270 plus which quadrant? Third quadrant, right? So the third quadrant. What sign is your function? Our function sign is negative. So this will change because we have a maximum of 270. This will change to its cofunction identity, which is cos A times sine B. So this is equal to sine A cos B minus cos A sine B, which is the same as what we're trying to prove up here. So we're done. So now they want us to find the general solution for this thing here. This is 5.3.2. They want us to find a general solution for sine 48 cos x minus cos 48 sin x is equal to cos 2x. They want us to find the general solution to this thing. No problem. What do we do from here? You can see that this thing here, the left hand side, look exactly like this. The A is 48, your B is x, A 48, B is x. So if you look at this, you say this is similar to this thing here. So you reverse this and say this is equal to sine 48 minus x is equal to cos x, cos 2x actually. Fine. What now? you know that you can reverse this so that it looks like cos as well. So if you reverse it, there are two ways to reverse it, this way or that way. Right? What do? We say, okay, let's reverse it maybe this, which way? You can do it both ways, right? Let's start with the 90 minus way. So we can say that this sine 48 minus x, it is equal to cos 90 minus 48 minus x, right? So these two are equal, this and this are equal. Therefore, on this left hand side, you can substitute just this and just say cos 90 minus 48 minus x is equal to cos 2x, right? What do we do from here? So we can simplify. Actually, we don't have to go that far. What we can say is we have cos 90 minus 48 minus x equaling cos 2x, right? If these two things are equal, which means these angles are the same, right? Which is your 90 minus 48 plus x is equal to this thing here, which is your 2x. So, which means if this is equal to if the left hand side is equal to the right hand side, which means these angles should be equal to these ones. So they are equal. What do we do next? We say, okay, because I want the general solution, so it's 90 minus 48 plus x plus 360k is equal to 2x, where k is an integer, of course. So what do? We say 90 minus 48, this is 42. So get that this is 42 plus 360k is equal to x, because you transform that to the right side. So this is your solution. First one. The second one, we'll get it from here and say, okay, now we'll say now this this part here, which is the left hand side, this part now, it is also equal to what? It is also equal to cos 270 plus 48 minus x. This is also equal to 2x. Do the same thing. If this left hand side is equal to the right hand side, that means these angles are exactly the same, which is this part and that part. Therefore, your 270 plus 48 minus x is equal to 2x. But because you want the general solution, the 270 plus 48 minus x plus k 360 is equal to 2x. What do? So your 270 plus 48. So this is 318 plus 360k is equal to 3x. Then divide by 3, divide by 3, divide by 3. So x is equal to 318 divided by 3, which is 106 plus k 120. Your period for the second time looks like this, 120. Done. Move on to 5.4. Go to clean the part and you do 5.4. So 5.4. Simplify this thing here to a single trigonometric ratio. They wanted to simplify this thing to a single trigonometric ratio. What do? Obvious one is this one here. Break this down. Get sine 2x plus x plus sine x divided by cosine 2x plus 1. right? Then you expand this compound angle here, is sine 2x cos x, right? Plus cos 2x sine x, then plus 1, plus sine x, which is this one, plus sine x. So this part is this part here, all divided by cos 2x plus 1. Right? What do? We decompose this compound angle here. So if we decompose it, what do we get? We get 2 sine x, right? Cos x from this is this part here, times cos x, which is that one, plus cos 2x plus cos 2x, which is this, cos x plus sine x, all divided by cos 2x. So it's 2 sine x cos x, which is this, cos x, which is that, cos 2x, which is this one here, sine x, which is should be sine x here, should be sine x plus another sine x. So this cos is this one, this guy is this guy, plus sine x, which is that. What is the next step? Let's just simplify it nicely. So we have 2 sine x cos x, or times cos x, plus, this is a plus here, plus cos 2x sine x plus sine x, all divided by cos 2x plus 1, right? Then we take sine x as a common factor. So we have sine x outside. Inside we have what? Inside we have cos squared x, because cos times cos x times cos x is cos squared x, plus cos 2x, right? Plus 1. That's what we have inside. All divided by what? All divided by cos 2x plus 1. That's what we're left with. You know what this is. So we have sine x into cos squared x plus this. You can expand this, or you can change it and put its identity. This is 2 cos squared x minus 1, which is this part here, is this, then plus 1, which is that one, all divided by 2 cos squared x minus 1, which is this part, then plus 1. No problem. What do? We say, okay, we'll clean this part and try to finish it. We're trying to finish this. So what do we have on top? We have sine x into what? Cos squared x, which is this, plus 2 cos squared x, right? Actually, we lost something. We lost a 2 that was sitting here. So there should be a 2 here. Should be 2. This 2 should also have a 2 here. Yes. So we're supposed to have a 2 sitting up front here. So we have 2 cos squared x, which is that, plus 2 cos squared x, which is this, minus 1 plus 1. Close the bracket, all over 2 cos squared x minus 1 plus 1. So this and that go away, this and that go away. So on top we have sine x into 4 cos squared x, 2 cos squared plus 2 cos squared is 4 cos squared x, all divided by 2 cos squared x. Then if you multiply the top with 4 sine x cos squared x, all divided by 2 cos squared x. So this and that go away. So I'm left with 4 over 2, which is 2 sine x. We're done. This is how to do this one. Yes, I think this is the way. I hope this question does make sense to you, as it does to me. Thank you for watching. Cheers.